So hello everyone, welcome back to my channel, and I'll tell you the first thing. Please subscribe if you have not subscribed, or if you are new to the channel. That will help me a lot. That is the case, and we'll start with the problem that we are doing today. So there is one problem in LeetCode which is named trips and users. So basically it is saying there are two tables, which is one is trips and another one is users. We have to basically find the cancellation rate, which is equals like, if I will show you this one, then you will understand what is it. So basically there are client ID and I'm sorry, client ID and driver ID, and here is another users table which has both client ID and driver IDs, with one column if it is banned or not banned, and with another column if it is a client or driver. So basically what it is saying, if there are requests made by unbanned clients and including unbanned drivers. Okay, so here there should not be any driver or client which is banned. Like suppose 2 is banned, so 2 should not be included in the result setter. Okay, so after finding those combinations, if you have to find the total requests made in one day, and you have to divide the cancelled number of cancelled rights. Okay, so basically it is saying you have to filter out the banned users. Maybe it is client and maybe it is driver. So suppose one driver is not banned, but there is one client which is banned, so you have to exclude that from your result. Okay, so this is a you can see it is labeled hard, but do not think it is that much hard. You just have to like find the logic, and you just have to formulate the logic. So let us see how we can solve it. This problem is like description is not much right now. So as usual, I will copy and paste the code as I already completed writing it. The first step we are doing is we'll just filter the data frame. We are making one data frame trip. In that trip, what we are doing, we are taking the date range which is specified, pre-specified. Like we have to find in between these two date ranges. You can see 2010-1 and 2010-3. So date column is available in trips, so we have to filter that 2001, 10, 2013, 3. Okay, then we are filtering the unbanned users, the users which are not banned, by filtering banned equal to no and role equal to client. Then we are again filtering another data frame which is band equal to no and role equal to driver. So we are making three data frames, each with specific details. One is filtered to date range, another is filtered for users, another is filter for driver. Next what we will do, next we will join these three data frame, because we have to find combination of unbanned users and unbanned driver. So first we are doing not banned merge users. We are basically merging this trip. This is the left table. We are merging with not banned users. Here are only users which are not banned. So we are merging as inner join left on client ID and right on users ID. Okay, so this will result in on table which will include all the users which are not banned. Okay, this will filter the not banned user first from the trips table. Then again we are merging with this driver. So there will be some drivers also who might be there which are banned. So we are merging with not banned merge users. Basically this is the result data frame we created in one step before. So we are taking the driver ID, status and request ID, because we do not need any other columns after the resulting data frame. There will be many columns, but we do not need those columns, right? We only need driver ID, status, request start. So we are merging not band driver, this data frame in which only on band drivers are present. Okay, so we are merging on left on a driver ID and we are right on users ID. Okay, because here users ID is present and in this one driver ID is there because we took driver ID. So basically you understood why you took only driver ID, because you have to join here. Okay, so basically this will result in one data frame which will include driver ID, status and request start, which is basically the records of both on-band clients and on-band drivers. Okay, there will be no record which will have a band client or band driver. Then what we are taking, so basically what is our resultant data frame? It should have the cancellation rate as one column and there is nothing else and there is one day. Okay, so what we are doing here, we are taking cleaned as status and request start. Request start is the date field you can see here and status is completed or cancelled. So we do not need any other columns because basically we are going to take the count. So any field is okay with the date column. Okay, so next step what we are doing, we are filtering the cancelled requests. Okay, they in this cleaned there will be both completed and cancelled requests. So we'll filter out both only cancelled request to another data frame cancelled. So clean status str dot starts with cancelled. So I do not want to take any specific, like this string is there, so there might be another string. So what we are specifying is if the row starts with cancelled, then tag that row as a cancelled row. Okay, so we are then grouping by request start, we are grouping by the date column. Okay, and we are taking the count of status, like in which day how many cancelled counts are there, then we are resetting the index to return it as a data frame. Okay, I am not showing you the results, as if you are solving this problem you can like go to LeetCode and you can try this code and you can see the result of each step. Okay, then what we are doing, we are taking count see here we taken the count of cancelled, and we again will take the count of all the requests including cancelled and completed, which is present in the cleaned data frame. Okay, so we are grouping by request start again with this one and taking the count of status and we are resetting the index to return it as a data frame. Okay, so basically in this count cleaned we have the count by day, which is both cancelled and completed, and in this cancelled data frame we have both records for only cancelled writes. Okay, so here we are taking one data frame, another data frame which is final. So we are count cleaned, like count cleaned here all the records present. So basically some day will be there which might have only one request and which might be completed, so it will not be present here. So we are taking left table as this one because here all the days are present. Okay, so we are taking count cleaned, merge, cancelled, we are joining with this data frame, we are doing left outer join because we have to return all the dates. Okay, even if there is no cancelled order in any one day, we have to return as 0. Okay, so we are taking left on request start, another right on request start also. We are filling the values as 0 because if some day is here in this data frame which is which has no cancelled error, so this date will be not be here. So if you after joining in cancelled, the field will result as null. Okay, so you are just filling that null value with 0. Correct. And we are taking the final cancellation rate. We are creating another column as cancellation rate. So here what we are doing, final status y will be there, because the left table after joining, the left table will be suffixed with x and the right table will be suffixed with y. So the right table is basically the cancelled count, so we are taking the cancelled count divided by the total count, which will be status x and status y. We are rounding it to 2. So let me show you the final data frame. Maybe it is a bit confusing because I did not show any result this time, but yeah, if you are trying, if you are solving this problem and if you are using this code, then you can try. So you can see status x is there, status y is there. Basically this is the cancelled count, this is the total count. So 1 by 3 0.33, 0 by 2 is basically 0 and 1 by 2 is 0.5. Okay, so basically that was our aim. Next we will just take the required fields with renaming them, and we'll return those fields only because we do not need anything else. So return the data frame in correct naming format, because request art is in the expected output, it is renamed as day. So we are taking these two fields, we are renaming request art as day, axis equal to 1 we are mentioning, and we are returning that final data. Okay, so if you will return, you can see it will be accepted, and we will submit this code. So again, as usual, we are at the last, means there are other better solutions available here also. You can click anywhere here and you can get the best solution to our solution. But yeah, the thing is you should try by your own. Also you should build your own logic. You cannot get one which what we call, we cannot get an optimized result when you are starting with the code. Okay, first you write one messy code, one lengthy code, then you are slowly you will optimize it, and at the end you will try and get the best code for your query. Okay, so do not try to optimize the code from starting. Just build the logic, write the code, does not matter how much length is it, write the code so that you will understand. Also if you are writing a lengthy code, that means you are using different kinds of things, different kinds of methods, different kinds of functions available in pandas. So that way you are learning. Okay, you are learning how to write, how to use those functions, how to use those codes. So lengthy code does not matter much. What matters is how you are solving the problem and how you are approaching, what is your logic. So basically that's it for this video. I hope you learned something, and I hope this you will try this problem. Please subscribe to my channel, please like this video, and also share if someone is learning their pandas, or if someone is there who is trying to solve problems. So basically this channel is all about that, and it might help them in some way. So please subscribe, please like. I will see you in the next video. Thank you very much.